Hello guys. Several problems on the coming example involve inverse function. An inverse function can be given either with such a small symbol -1 or with the prefix r. Sine inverse can be written like this or like this. And we usually solve such a problem by giving it in an alternative form, like switching the values. Y equals sine inverse of -1 is almost the same as the statement that sine of y equals -1. So arcsine, the function arcsine, usually represent an angle. So we can tell that it's a real number, but it is easier to think about it as an angle given in radians, or we can also use degrees. It does not influence the answer. So to solve this, we must write it in alternative forms. Sine goes to the other side of the equation, and it is not inverse anymore, just sine. So y equals sine inverse of -1 is the same as sine of y equals -1. And then it's simple, we just find this value of y that pass for this equation. So, and you should remember that negative sine inverse is from the fourth quadrant, and it is from 0 to -π/2 or from 0 to -90 degrees. So sine is the y-coordinate on the unit circle, and y-coordinate is equal to -1 at this point, and it is the -π/2 on -90 degrees. So y must be equal to -π/2 on -90 degrees. Another example of cosine inverse of -1. So negative arc cosine is given by definition in the second quadrant. So, and cosine is the x-coordinate. So let us write it in alternative form. So cosine without inverse, cosine of y equals -1. Cosine equals to -1 at this point, and this is the angle equal to pi radian on 180 degrees. So y equals pi. And last example, y equals tan inverse of 1. We write it in an alternative form. Tan goes to the left. Tan of y equals 1. What point on the unit circle has tangent equal to 1? It is 45 degrees. So here x and y are the same. Y over x is 1. So tangent of 45 degrees or pi/4 equals 1. So y equals pi/4 or 45 degrees. Y equals arcsine of square root of 3/2. The same method, we write it without arcsine or without inverse function. Sine of y equals square root of 3/2. If the arcsine is positive, then we are in the first quadrant. In the first quadrant, the angle of 60 degrees has the sine equal to square root of 3/2. That's why y must be equal to 60 degrees, or depending on what is required in the problem, or y equals pi/3. Let us also find arc cosine of negative square root of 3 over 2. Write it without inverse function first. Cosine of y equals negative square root of 3 over 2. So we deal with inverse function. Cosine inverse is negative in the second quadrant. And the cosine is the x-coordinate. So x-coordinate is square root of 3 over 2. You know that it is the reference angle will be 30 or 60, and the cosine is the longer leg and sine is the shorter leg. Then it is this angle, the 30 degrees reference angle, or theta y equals 150 degrees, or y equals 5 pi over 6. In the first examples, we deal with special angles, or 30-60 triangle, or 45-45 triangle, or quadrantal angle. In the next problem, it is not a special angle anymore. Y equals cosine of tan inverse of -4. So tan inverse, sine inverse, cosine inverse, it is an angle. Let us call this angle A, for example, and make a sketch of A. So tan inverse, or angle A, is negative. It means it must lie in the fourth quadrant. And so we have such an equation: A equals tan inverse of -4. We can rewrite it in alternative form, bringing trigonometric function to the left without inverse sign. Tan of A equals -4. So tangent is, by definition, y over x. It's another y. It's a y coordinate on the unit circle, y over x. So we can take y equal to -4 and x equal to 1 and sketch the angle. So y equals -4, 1 is x, and this is our angle A. If you look at this small right triangle, we can find the hypotenuse. We usually denote it with r. By Pythagorean theorem, r squared equals x squared plus y squared. R squared equals 1 squared plus 4 squared, so plus 16. R squared equals 17, and r equals square root of 17. Of course, it's positive since it is distance. Now, let us return to our original problem. We want to find cosine of A. So this y that we have in this problem is the cosine of the angle that we called A. This is the sketch of this angle. And cosine of A is x over r. In this formula, x and r from the graph. X is the x-coordinate, r is the distance from the origin. X is 1. We consider this point on the right triangle. And r, we have just found its square root of 17. So cosine of A is 1 over square root of 17, or let us rationalize denominator. We multiply by square root of 17. Numerator and denominator is square root of 17 over 17. So this is the cosine that we wanted to find. Now let us solve the equation. 2 cosine x plus square root of 3 equals 0. First step, we must isolate trigonometric function. For this purpose, we subtract this number from here, subtract square root of 3 from the left and from the right. 2 cosine x equals negative square root of 3. Then we divide by 2 on the left and on the right. Cosine x equals negative square root of 3 over 2. In the last step, let us find all values of x that have this value of cosine. Look at the unit circle. Cosine is negative in the second and the third quadrant. Negative square root of 3 over 2, you know, is the cosine of a reference angle 60 or 30. And you see is the x is the longer leg, or the other leg in this 30-60 triangle must be 1/2. So the reference angle will be 30 degrees. 30 degrees, so we have two solutions. So let us give it in degrees. So usually if you are asked to find the solution on the interval from 0 to 360 degrees, you give the answer in degrees. If from 0 to 2 pi, you give the answer in radians. So let us give the answer in degrees. And the first will be 180 minus 30, or 150 degrees. And the second 180 plus 30, or 210 degrees. So we have the next equation, sine of 2x plus square root of 2 cosine x equals 0. Here we have two trigonometric functions, and they even have different arguments. Here we have 2x, here we have x. But we can change this equation a little bit, applying the double angle identity. So sine of 2x equals 2 sine x times cosine x plus square root of 2 cosine x equals 0. Now look at this equation. We have two terms, and these two terms have the same factor, cosine x. We factor out cosine x. Cosine x times 2 sine x plus square root of 2 equals 0. Now the product of two factors equals 0 means that each of these factors can give a 0 of the equation. So if cosine x equals 0, we have a solution, the product is 0. Or when this sum equals 0, it is also a solution and the product is 0. So either cosine x equals 0 or 2 sine x plus square root of 2 equals 0. With cosine x is simple, so we just look at the unit circle and find the points where cosine equals to 0. So again, this x is not this x on the unit circle. This x is a real number or a theta. Cosine is the x-coordinate on the unit circle, and it is equal to 0 at this point and at that point. The first point is pi over 2, and the second point is 3 pi over 2, or 270 degrees. So we got the first two solutions of the equation, and now the second equation. And here we should first isolate trigonometric function. Let us subtract square root of 2 from the left and from the right. 2 sine x equals negative square root of 2. Then divide by 2 on the left and on the right. Sine x equals negative square root of 2 over 2. And now let us look at the unit circle. where we have the values of sine equals negative square root of 2 over 2. Sine is negative in the third and in the fourth quadrant. Negative square root of 2 over 2 is a special angle 45 degrees. So reference angle is 45 here and here. So we have pi plus pi over 4 or 5 pi over 4 here, and 2 pi minus pi over 4. 2 pi is the same as 8 pi over 4. 8 pi over 4 minus 1 will be 7 pi over 4. So another two solutions. So altogether we have these two solutions: pi over 2, 3 pi over 2, 5 pi over 4, 7 pi over 4. All these four numbers satisfy the original equation. The next equation, square root of 3 times tangent 3x plus 1 equals 0. So we have here an argument as multiple angle. So here we don't have to use any formula, so we isolate for this trigonometric function. We subtract 1 from the left and from the right. Square root of 3 tangent 3x equals negative 1, and we divide by square root of 3. Tangent 3x equals negative 1 over square root of 3. So now we have to find the values on a unit circle that have such a tangent. And we want to solve this equation for all solutions. So here you should remember that tangent has a period 180 degrees or pi. So it means to our solution we can add 180 times n or pi times n. Tangent is negative in the second quadrant and in the fourth quadrant. And we know that 1 over square root of 3 is a tangent of a special angle of 30 degrees. So tangent of 30 must be smaller than tangent of 60. So if you remember that one of them is square root of 3, then another is 1 over square root of 3, then square root of 3 is the tangent of 60, and 1 over square root of 3 the tangent of 30 degrees. So the reference angle is 30 degrees here or 30 degrees here. And then we have several ways how to write the answer. Since we solve for all solutions, we can write that it is negative 30 plus 180 degrees times n, or we can write 150 plus 180 times n. N is any integer. So it's actually the same, since if n is 1, for example, in this first equation, then we add 180 plus negative 30 and we will get 150. From this equation, if n is negative 1, then we get 150 minus 180, we get negative 30. That's why we can take either this or this. Since you have multiple choice, you will see what will work better in your problem. So then, another important thing, it's not the solution, it is the value of 3x. So 3x equals either this or this. So either negative 30 plus 180 or 150 plus 180. It's the same. So let us, to find x, we must divide this equation by 3. So let us consider this option with positive. So 3x equals 150 plus 180 times n, and we divide by 3 this equation. We get x on the left and 150 over 3, 50 plus 180 over 3, 60 degrees times n. So this equation gives all solutions of the equation with tangent of 3x. The next equation involves arctangent or inverse tangent of x. And to solve it, we must first isolate trigonometric functions. So we have to divide by 6 on the left and on the right. Arctan x equals negative 5 pi over 6. The next step when we deal with inverse function, we must write it without inverse function. So we move trigonometric function on the other side of the equation without arc. So arctangent x equals negative 5 pi over 6 means that x equals tangent of negative 5 pi over 6. Let us find this trigonometric function value using the unit circle. Negative 5 pi over 6. We move in the clockwise direction. So 1 pi over 6 before pi is negative pi, is negative 5 pi over 6. And we want the tangent. Tangent will be y over x. So y is negative 1/2. X is negative square root of 3 over 2. So the tangent will be negative 1, positive 1 over square root of 3. In the third quadrant, tangent must be positive since x and y coordinate of the point both are negative, so the fraction must be positive. The reference angle is pi over 6 or 30 degrees, and you know the tangent of 30 degrees is 1 over square root of 3 or square root of 3 over 3. And then we move to the 7th chapter. We have a triangle with one angle 45 degrees and two sides 5 and 8. So it could be an ambiguous case, but the question is to find sine of b. So, and maybe it could be two different triangles, but we will not deal with this. We only want to find sine of the angle b. Oh, sorry, I must add the letters here. This is the angle A, B, and C. And we can write the law of sines for this triangle. When we solve for sine, for angle, then we take law of sines in this form. Sine of b over b equals sine of a over a. Then sine of b, our unknown, is in the numerator. It will be easier to solve. So we multiply by b, and sine b equals b sine a over a. And let us substitute. B is the side that is opposite to the angle B. That is 5 sine of 45 degrees and divided by A. A is the side opposite to the angle A. Is 8. Sine of 45 is square root of 2 over 2. So sine b equals 5 times square root of 2 over 2, and 8 is also in denominator, or 5 square root of 2 over 16. In the next problem, we want to find the area of a triangle ABC. We know one angle and two sides adjacent to this angle. Then we can directly apply the formula for the area of the triangle. It is 1/2 the product of the sides that are adjacent to the angle. So if we have the angle A, then here we will have B times C and times sine of A. Sine of A of the angle between these two sides. And we substitute the numbers. B is 12, the side opposite to the angle B. C is 10. And sine of 60 degrees is square root of 3 over 2. And let us simplify it a little bit. In the numerator, we have 12 times 10 times square root of 3. In the denominator, we have 2 times 2, or 4, and we can divide by 4 in the numerator and the denominator, or divide by 2 times 12 over 2 will be 6. 10 over 2 is 5. So we have 6 times 5, 30 times square root of 3. This is the area of the triangle. And one more triangle. Again, we know two sides and the angle between them, and we want to find the third side. It is the case for the law of cosines. We can find the law of cosine for the side x. X squared equals first side squared, 5 squared, plus second side squared, 7 squared, minus 2 times the product of these two given sides, times 5 times 7, times cosine of the angle between them, cosine of 45 degrees. So 25 plus 49 minus 2 times 35 times square root of 2 over 2. 2 and 2 can be cancelled out. So x squared equals 74 minus 35 square root of 2. And the side x itself is the square root of this difference. Square root of 74 minus 35 square root of 2. Let us consider the vector u given by two components, x component and y component, and we want to find the direction angle theta. Let us make a sketch for this angle. We know that the x component is positive 10 square root of 3. Y component is negative 10. So the end point of this vector, the terminal point, will be here. In the standard position, the vector starts from the origin. So, and we want to find the angle theta, this positive angle from the x-axis to this to the vector. Knowing the x and y components of the vector, we can find the direction angle. The tangent of theta is y over x y component is negative 10, x is 10 times square root of 3. So tangent is negative 1 over square root of 3 or negative square root of 3 over 3. You know that this is the tangent of negative 30 degrees or 360 minus 30, 330 degrees. So theta is 330 degrees. And a couple of problems from chapter 8. Very simple problem, don't be scary. So let us find the product of two complex numbers given in trigonometric form. You know that this is the short form. Cis of 200 degrees is the same as cosine of 200 degrees plus I sine 200 degrees. So, but here we want to find the product of two complex numbers. 15 times cis 200 times 6 cis 130 degrees. And we have a product theorem or product rule for multiplying complex numbers in trigonometric form. So the amplitude or magnitude must be multiplied as for usual numbers, 15 times 6. And angles must be added, and you get a new complex number, cis of 200 plus 130. So let us simplify this. 15 times 6 will be 90. Cis 200 plus 130 equals 330. Cis 330 degrees. And we want to give this number in algebraical form. So we write this in the long form. So 90 times cosine 330 plus I sine 330. So that's why C is in the short form CIS. Now 330 is here on the unit circle. Cosine is positive square root of 3 over 2. Sine is negative 1/2. Substitute 90 times square root of 3 over 2 minus I 1/2. And let us multiply by 90. Will be 90 times 1/2, 45, square root of 3 minus 90 over 2, 45 I. The next problem, raised to the 10th power, cis 24 degrees. So for raising complex number in the power to the power, we have a beautiful de Moivre theorem. So if you would have a coefficient here, just raise it to the power 10, but we don't have a coefficient, and the angle must be multiplied by the exponent. So it is equal to cis 24 degrees times 10, or cis of 240 degrees. On the unit circle, it is the point in the third quadrant, 240. Reference angle is 60. This point, so the y component is negative square root of 3 over 2, and x component is 1/2. So writing to the full form, it will be cosine of 240 plus I sine of 240, or negative 1/2 minus square root of 3 over 2 I in algebraical form. Let us plot the number given in polar coordinates. So the first number represents the distance from the origin. The second number is the direction angle. So the distance from the origin is 25 units. The angle is the angle in a positive direction from the x-axis. 350 degrees lie, 15 degrees lie in the fourth quadrant. The complete circle is 360. The third quadrant is 270 degrees. 315 is in the middle. So the question is, what is the quadrant of this number given? Is 4. 4. And the last problem is parametric problem. Find the ordered pair xy when it is given that x equals 12 cosine t, y equals 12 sine t, and t is 3 pi over 4. So t is a parameter in this system, and we substitute 3 pi over 4 into the equation for x and y and find this ordered pair. So x will be equal to 12 cosine 3 pi over 4 and y equal to 12 sine 3 pi over 4. 3 pi over 4 is in the middle of the second quadrant. Sine is positive, cosine is negative. Both have the absolute value square root of 2 over 2. So we substitute x equals 12 times negative square root of 2 over 2, and dividing by 2, 12 and 2, we get negative 6 square root of 2, and y is 12 times positive square root of 2 over 2, 12 divided by 2, 6, positive 6 square root of 2. So the ordered pair xy is negative 6 square root of 2 and positive 6 square root of 2. So if you have any question, you can always call or arrange a Zoom with me. If you will have questions during the exam, you can always call during the exam. I'm usually available all the time on the day of the exam. And I wish you good luck and thank you.